So if everyone can just consent to that, I'm going to start sharing my screen again.
So that term goes there.
Okay.
This one.
So what we're going to explain, let me just stop sharing again for a second. Yes, it is recording. Record on this computer. So we are moving into one-step equations. Tomorrow, I will be teaching you the art of two-step equations, but this is the most important part that I want you to realize. When you move a term to the other side, the sign in front of it changes. And right here, I have written variables equal signs numbers. What that means is we want all the variables on one side and all the numbers on the other side. So this is the analogy I gave last week's class. So my daughter's in kindergarten right now. And it was very sad for a little bit because one of her friends was in the other kindergarten class. So what usually happens at recess in a normal non-COVID environment? Even if your friend is in another class, what happens at recess? Can someone tell me?
And then just
Jordan. Yeah, you just, it doesn't matter. You see everyone at recess. But right now in a COVID environment, they have these ropes that are dividing the playground area. And if your friend is in another class, then you can't cross the rope. So it's very sad. She just waves to her friend, and her friend, well, this was at the beginning of the school year. Then they decided this was so sad for the kindergarten kid that they put all the SK kids in one class. So now my daughter can see her friend at recess. But before, she would come home every day and say, Mommy, I could just wave to her past the rope. I couldn't play with her, okay? So very sad scenario, but we're gonna use that for algebra. We're gonna think of the equal sign as the rope dividing the classes, right? That's what the original x plus 4 is equal to 12. So 12 is my daughter. That actually happens to be her birthday too, the 12th. And her friend is positive 4. Her friend desperately wants to come to her class, wants to cross the rope and play with her at recess. But something has to happen. When the number moves to the other side, now we're not talking about kindergarten anymore, but we're talking about the process of algebra. You are able to meet your friend on the other side of the rope, but something has to happen. The sign of the number has to change. So instead of positive 4, it turns into a negative 4. Okay, so that's when what I mean by when you move a term, the sign in front of it changes. Now the unit guides that you have, remember, they were written a while ago before I was even a math teacher. So it's not necessarily, there's a strategy in there, but in my lessons, I'm trying to teach you the easiest strategy with like the least amount of steps. So the unit guides are a little bit more detailed. They want you to balance both sides. What I'm going to show you in my lessons is all I expect you to do on the test. When you're moving something to the other side, the sign in front of it changes. So now I'm left with one variable on the left-hand side, the x, and when the positive 4 moves over to the other side, it turns into a negative 4. Now I can solve x is equal to 12 minus 4, x is equal to 8. Now, later on when we do our hallway activities in November, we're going to actually attach scenarios. Right now, these are just variables and numbers. Later on, what algebra is useful because it can help us solve something that we don't know the answer to. So for example, I can attach algebra to sports. I can attach algebra to finances. So if the student council is planning a dance and they have to figure out how much money to spend, we can actually use algebra to solve it, right? How many athletes are in this room? How many people like athletics or sports in this room? So there's something that we're going to give you called the athletic banquet problem, which is really associated with sports in our school. So you can earn athletic awards every year, a junior letter, senior letter, athlete of the year, award of excellence, but you need a certain number of points in terms of playing sports. So we can figure out in order to earn a junior letter, senior letter, we can use algebra
the
to
other,
figure out
right?
how many points
two
you
times
will
one test,
need,
that
and we're
means-
gonna actually do that in our hallway
Well,
math
that's
later
what
on.
this.
So math is
I
not
told
always
them I
about
want-
just
that's the
random
ratio
variables
of
and
their
random
intensity.
numbers.
So
It
I don't
can be
know
always
the
attached to
exact
real world
values of what I
scenarios.
want.
But
Question
before I
doesn't
can
tell
do
you
the
that, but I
word
don't need
problems
to know.
with you,
All I
we have to
know is
kind
that
of learn
if I
the
compare
steps of
I2, I1
algebra. Okay, does everyone understand
times
that?
I,
So the athletic banquet will be a problem or a question that we do later on. Let me just put some screens up so I know how far I'm gonna go with you.
I replace I2 over I1 with 2, because it's double the interest, right? If I divide their intensities, I don't know what they are. but I
Okay,
compare.
there
All I know
we
is that when I
go.
compare them,
So
it's a
let's
triple
go
divided
back
by
to
3,
the
so
full
it's a double
screen.
And
So the first
now we have
question was
equations
quite
to solve
simple.
for beta
If
two.
you can read, write down the
So
next
we just wanna get
couple
beta
of
two. So
questions,
this
number
is
1 and number 2
seven.
into your notes. We're going to talk again.
And this
X
is calculable here.
is
This
a
one's not
variable, and then we have
Remember that
negative
this is
2
all
on
about, right?
one side, the left-hand side with the X, positive 8 on the right-hand side. When you're doing your
So-
algebra, you want to think the variables are friends, the numbers are friends.
Twice,
The
but
negative
if you
2 desperately wants to
calculate that,
join
then you should
its
get
friend
7.
positive 8.
Okay,
Over
stop
here,
here,
the
'cause I
positive
think this
7
first value is
desperately
2.01.
wants to join its friend
Okay.
positive 5 on the
And that's it.
playground, okay? And that's how we're always going to think of algebra. Variables, numbers, friends on the playground. That's what we're
That's
going
where I wrote that line twice.
algebra.
So we can go right from,
to.
so just remember, it might tell you if it doubles or triples or whatever, just replace the ratio with that number. Sorry, somebody have a question? Yeah. right. Yeah. So sometimes they're going to give you both sound levels and then ask for the comparison of the intensity. Sometimes, like, they're always going to for enough information where you plug in the equations for any of these word problems and just solve for whatever's. The trickiest part, I think, is just setting up the understanding how to go from the language to plugging stuff in. And then everything from there is just using the logarithm.
Okay, so when negative 2 joins its friend on the playground, now the X is already happy on the left-hand side, right? It doesn't always have to be on the left-hand side. So sometimes variables can be on the right-hand side, but numbers can be on the left-hand side, right? That doesn't matter. What matters is what side it wants to move to join its friend on the playground. Now, X doesn't have any
One
friends here. X is a lone wolf. X is good by
So-
itself. So what happens when I
Okay, we'll
move
do
the
a-
negative 2? How am I going to rewrite this
So this
question,
is
Ananya?
growth or decay problem, right?
Pardon? A little louder.
Usually
A
I do a
positive
calculation
2,
is-
yes,
is
it turns
okay, so
into
this is
positive
just
2,
the
but we can't forget to write the left-hand
population of the
side.
town is decreasing.
So the left-hand side will have the X. Then we have the equal sign, which is dividing the playground. And then negative 2 moves over to the other side, turns into a positive 2. So my final answer is X is equal to 10. X is equal to 10.
The decay problem, right? It's going, starting with some amount.
My daughter
and
will be so happy I
going down,
used
down.
her in a math
The
lesson.
key here is remembering how we set up the base of our exponential for these ones. Because
Now, the cool thing about
know
algebra
what the
is
decay rate is.
unlike the other tests that you've
1.6%.
done where
but
you
lots
have
of
to
students
rely
forget a lot of
on
times, just remember,
your strategies
how we find
or your notes to
v
feel
values, so
confident
for
that
our
you're
y
doing,
equals
getting the right answer.
A, B,
For left-hand
Yeah,
side,
that's
right-hand
for
side
formulas.
algebraic equations, you can always check
For
whether
decay
your
problems,
answer is
V
correct.
is equal to
So
one.
you know how I give you a lot of time for
So,
tests, a lot of extra time?
What is
If
our?
you have that extra
Well,
time, you
it's
could actually
66%.
use it, making
each
sure
number
that your
that's-
answers are 500%
Remember, take that one
correct.
six.
And I'm going to
Divided
show
by
you how to do that. So we're going to
And
write the
you
problem
have
again, but this
1
time I'm
minus
putting it in
0.016.
table form. The left-hand side of the equation is x minus 2. The right-hand
These
side
are
of the
our
equation is 8.
Is
Now, wherever I see
0.94.
x, so my over here, my
That's
x
the V value.
is comes
One of the
first.
trickiest parts
I'm
is
going to
solve.
substitute the number 10 in for x.
Sorry, can you
So
repeat?
instead of x minus 2, I've written the left-hand side of the equation as 10
So-
minus 2. And I'm only solving
This
the left-hand
here
side. So 10 minus
is your
2
R value?
is equal to 8.
The B
The
value
right-hand side of my
is-
equation was originally
you
8.
said it for K
So it just
problems.
continues to be 8. So I know that my answer is correct if my left-hand side is equal to my right-hand side. Everyone write this down. This
So
is
the
the
range of
strategy. If my
0.6%
left-hand side is
converts to
equal to the
decimal,
right-hand side,
yeah,
my
0.06,
answer is correct.
so divide by
Even
100.
over there in grade 12 math, we can use this
So this would equal
substitution to check
0.9.
if your answers are correct. So this is a big,
That's your-
huge part of grade 10 academic,
That's probably
actually,
the trickiest part. Just
is
remembering
this
that
strategy,
usually
checking the
sometimes I
left-hand
see
side is
students
equal to
they
right-hand
add
side.
one and
Now,
say
I'm not going to ask
or
you on
just
computer
put
tests to do
1.6
this,
and
but if we
convert
were in
to
a
decimal.
regular, a grade 90 stream course writing tests in the test center, there would
So
be
this
some
is the
questions where I would
base
say solve
or-
and check.
The base of your expression.
Now,
So there's B. This is how we calculate.
notice I'm always using this process of
There's growth problems, it's
substitution
1+.
to check my answer. I'm not going to do that for the whole lesson,
And
but
then
I will
I think
do
we're
it
okay
for the
with this,
next
right? The
question as well.
20,000
So
is the
solve
beginning
and
amount,
check.
50,000 is the ending amount, and it's asking
So
us-
if my virtual students, please turn your cameras back on, please. It's not part of the recording
okay.
anymore, so
You're
just
on
want
one
to make
Sorry.
sure
So we're gonna have to
that
use
you are
logs.
there
So
and
first thing, you
listening
just
to the
divide both
lesson.
sides by 2,000, get rid of that base on the right. So we just end up with 0.7.
So we're going to go back to x plus 7 is equal to 5. I need you to tell me, how would I rewrite this question
So again, I mean,
so
you could-
that all the
Good.
numbers
Do a
can be
variable.
with each other on the
convert that to
playground?
logarithmic expression.
How would I write
The
this question,
base
Nicholas?
or the base
X
is gonna be
equals
decimal.
5 minus 7.
So a little bit-
Yes,
that's
good.
a
X
funky
is
way to
equal
do
to
it, I
5 minus 7.
think. You can
Now,
divide
a
both
good
sides and
question
go.
would be, does it matter the
Divide
order?
both
It
sides.
doesn't, as long as the 5
that
stays
up
as a
front.
positive 5 and the 7 is a negative
both
7.
sides
So I
by
could have
positive
even
7.
rewritten this as negative 7 plus 5, right? That would
end
be
up
the
with,
same
uh,
thing. You wouldn't lose any marks for that, as long as the terms have the proper number.
Good, that's totally fine.
So now, when I solve this, 5 minus 7 is
Yeah,
equal
you get
to
about 72
negative 2, so x is equal to negative 2. This is one step equation. Remember, on the test, you're not rewriting the question. Your very first step should be moving
So
things
this
around,
section over
moving
is
things
how
to
many
the
times
proper
we come
side,
down
right?
here?
Not
Once.
rewriting the
That's what it
question on the test.
So
It
H
really
would be
wants you
one.
to make sure you get out of the habit of
If H
doing
is
that.
1, it'd be T over 1, which is still 2. Okay? So what Anton was asking is, how come we didn't write this exponent as a ratio?
Okay, now to check my answer, I'm going to first rewrite the question, x plus 7 on the left-hand side, positive 5 on the right-hand side. That's the first thing I'm going to do, rewrite the
Well, you don't
question.
need to write T over 1.
Now, what
That's
is
the
the
same.
only side that's going to require the substitution? The left-hand side or the right-hand side? What do you think? Yes? The left-hand side, thank you. So the left-hand side is going to require substitution instead of the x. Instead of the x, I'm going to rewrite this as negative 2 plus 7. Remember, the left-hand side has the x on it. The right-hand side only had the number 5. So I'm going to keep that as only having the number 5. So my answer is going to be 5. Oops. 5 is equal to 5. So that means
Plus, then you would have to divide. But since you're taking the product of both, if you multiply and divide by the same number.
okay, sorry. Let me clear that.
That's what we said, right? You're taking the product of.
So the left-hand side is equal to the right-hand side. And I would actually normally write that the left-hand side is equal to the right-hand side.
It's always T over H, so it's always T over H, so it's always total time
Okay,
divided.
that
by-
is
amount times the
key.
one.
Whenever you're checking your answers, you want to write
Well, that was
left-hand
the
side is
secret
equal to the right-hand side.
The
Let's
sign is
move to
still
the
the
next
denominator.
question.
The denominator.
If you
is,
can
in this
write
case,
those two
1 per
questions
year
down,
would be
let
1,
me check.
right?
We
So
are
there's the-
actually going to
the top
check
is the
our
total time, the
answers for
bottom
these
is
two questions
the amount of
as
time for one.
well.
Always that. Okay, so
So don't know why this is.
So that's a great question. We didn't cover any
Okay.
problems like that. You would have seen those in
Clear
grade 11.
that.
Where we've only been looking at compounded units, so you'll never have to worry about a question like that. But just to answer your question.
Okay, we're
um,
gonna start
take a look at
over
how we
here.
can-
How would I rewrite it
If it
so
says-
all the friends can be on the playground together?
Then you would need.
How would I rewrite this question number 3?
You
Any
guys-
ideas? A little bit more complicated because
is
there's a lot of negative
Usually in grade
terms
11,
here.
you're supposed to teach
Anyone
that,
know
so
how I would
would
rewrite this
almost
question?
Probably either glossed over. or
Well,
skipped.
first, the
Not
x
this
is
part,
going to
but
be
you
on the
guys wanna go
left-hand
try
side.
that
We're
in
gonna
grade
keep
11?
the x on the left-hand
So I'm
side.
saying
The
also-
negative
But
4
so
is going to join
um,
its friend
so
negative 1.
all that
Now
stuff.
remember, negative
We're
1 is
keeping it
not
simple.
moving, so it remains a negative 1.
Okay.
But when negative
that's-
4
that's a good
moves
one.
over to the other side, it becomes positive
Yeah.
4.
Cool. Good. That's all I wanted to check. So,
And now when I
yeah,
solve
good
this,
job, Greg.
x
So you
is
can
going
note
to
it,
be
but,
equal
what
to
you need-
positive
does anyone
3.
need,
X is going to be equal to
Chromebook,
positive 3.
iPad? So just put your hand up if you want to, like a Chromebook. Anyone else?
So when I'm checking my
you guys just
answer,
solve
I'm
this
going to
and-
rewrite the entire question, negative 4 plus x and negative 1. So when I plug it into the equation, since I found that x is equal to positive 3, well, negative 4 plus 3 is equal to negative 1. So my left-hand side is equal to my right-hand side. I am correct. Then you have this right down. Even the check part, okay, not just the equation, the checking part too, and then I would like you to do it on scrap paper to make sure that you have proper answers. But no, you don't have to do it, you don't have to type it for your solution. So that's a very good question.
Ms. Alberto,
Yes.
Chromebooks functional?
They were fully charged yesterday. I don't know if Heather charged them last night, but yeah, they were perfect. Fully stocked now.
Yeah.
Regular Mary one, they might even want to make the back like a test.
Yeah,
Digital testing
that's the dream.
is. Okay, what about 10 plus x is equal to positive 5? Can anyone tell me which friend has to join
Okay,
its friend on the playground? Nicholas?
10.
Yes, the positive 10. So when positive 10 moves over to positive 5, think like it has to get a ticket or something, or it has to, I'm not sure what it has to do, but it has to change signs. That's for sure what I know. So I would rewrite this as x is equal to 5 minus 10. Now, as I've mentioned multiple times, kids, you notice that our very first test was on integer rules. I tutor currently elementary school kids. Even in grade 4 or 5, we're doing integer rules with them because that's the #1 skill from elementary school that you need to carry over. Integer rules. And I have lots of videos on my YouTube channel, Miss Albert Math, on integer rules, because it came back with collecting like terms. It's coming back with one-step equations. It's part of distributive properties. So integer rules, I tell everyone, the one skill you need from elementary school in math, integer rules, okay? Very, very important. So on the test, I would expect you to know positive 5, negative 10, different signs. So when we combine them, we subtract the numbers and keep the sign of the larger number. So that becomes -5. Pretty straightforward to check our answers. X plus 10, we're plugging it into the equation where you would usually see the x. So my answer becomes positive 5 when I check left-hand side is equal to right-hand side.
Do you have any questions about any while you're writing, but you got the rest.
Okay, so this is what it means to solve and check. In your homework, if it says solve and check, then I do expect you in your homework to be able to check your answers.
But you guys need, I can-
Now, there is a copy of this slide deck in your in-class lesson notes on D2L. So you can kind of see where I'm going to take this concept as we go further. Okay. Two very straightforward questions over here. When the -7 on number 5 moves to the other side, it turns into a +7. When the +5 moves over to the other side, it turns into -5. For question number 5, when I combine 8 plus 7, I get an answer of 15. 5 minus 5 is equal to 0. So yes, x can be equal to 0 in some cases. That's perfectly okay. That's perfectly straightforward. So something that I want you to copy down in your notes. The trick to isolating a variable is to move numbers away from the variable by applying the opposite operation. So when those numbers were moving to the other side, the reason why the sign changed is because we were actually applying the opposite operation. And we're going to do that in our next example. Instead of the playground for multiplication and division, we're going to perform a little surgery on the numbers. So we're going to think about surgically removing something from the numbers. Okay, always helps when you're learning math, even when you get to grade 12, to attach a little story that helps you remember the rules of math. Math is a language. It's a language of logic. But sometimes it helps to have a little scenario that we attach to the language of logic to help us remember the next steps. We're not going to, since we're missing a few kids for take our kids to work, we're not going to do our hallway math today, but we will do it tomorrow. So yes, we're going to have a big chunk of that tomorrow for our classwork. Okay, I'm just going to scroll down so you can continue to write the rule, but we're going to tackle 2 more problems. So I want you to write number 7 and 8, as well as these words about the opposite operation. So 3 is stuck to the x because they've been multiplied together, the 3x on the left-hand side. X over 4, x divided by 4. That's another way with what we can say. It's represented as a fraction, but fractions are always represented as ratios where there's like the division context. So the opposite operation of multiplication is division. The opposite operation of division is multiplication. I want you to take some time to write that down. But we're going to start with multiplication. Whenever you see 5x, 9x, 12x, 14x, think of the 3 and the x have been attached together. Attached. And I want to be able to remove, surgically remove the 3 and the x. They're stuck together. I want to remove that. So I'm the math surgeon. And in order to remove the 3 from the x, to perform my surgery, I have to use the division tool. I'm using the opposite operation tool. So in order to remove 3x, whatever you do to one side, you have to do to the other side. So I'm going to write my question like this. 3x is divided by 3 and 18 divided by 3. 3x divided by 3 and 18 divided by 3. So this is my surgery. This is the operation of division that I'm using to surgically remove the 3 from the x. So I know that 3 divided by 3 will give me 1x. 18 divided by 3 is going to give me 6. So this is working. Let me just move this out of the way. Because my goal always at the end of this is to get the variable by itself, x by itself. Now, as we progress to the next lesson, we're not always going to use the variable x. Sometimes we'll use y, sometimes we'll use b, sometimes we will use z. Doesn't matter what variable it is, the variable always represents something, and it represents an unknown value. So I want to be able to see this. That's why it's so important for you to practice typing things on the sample quiz and also typing fractions or typing divide, division, ratios, because you have to be able to do this on your test, on the computer. You have to be able to type. Now, x over 4, that's a different type of surgery. When the question is represented as a fraction or a division question, the surgical tool that I'm going to use is multiplication. So that's what it looks like. I'm going to take the 4, and instead of division, I'm going to multiply the left-hand side by 4 and the right-hand side by 4. This is the #1 mistake that grade 9s make. They remember, oh, I have to multiply, and they'll only do it to one side and not the other. And algebra is all about balance, equal treatment. Whatever you do to one side, you do to the other. Let me give you an example. If I said, oh, my week 1 class, you don't have to do the algebra test, but the week 2 test class, you have to do the algebra test. Is that equal treatment? No, you're all in grade 9. So whatever I do for week 1, I have to also do for week 2. Equal treatment, right? Same thing with algebra. Whatever you do to the left-hand side, you have to do to the right-hand side. So when I multiply these terms, the 4s actually cancel out on the left-hand side. And I'm left with 1x is equal to 12. 1x is equal to 12. I get my answer right away. Now, this is the beginning of algebra. These are one-step equations. So it's not always going to be this simple. Sometimes it's going to be more complicated. And actually, tomorrow's lesson will be a bit more complicated, but you will be practicing together in your teams in order to perform or practice these 1-step and 2-step. Tomorrow I'm going to teach you 2-step operations. Okay, we're going to practice a few more, and we're going to stop at 2-step equations. So you can see we're going to get into more complicated questions. Let's do number 9, 10, and 11. Negative x is equal to 9. 5x is equal to 30. So again, we're performing 5 is attached to the x through multiplication. They've been attached, they're attached to each other. The -1 is attached to the x, right? I'm trying to remove it. In order for the x to be a healthy x, you need to remove the thing that is attached to it. We need to perform surgery. So I'm going to rewrite the first question as -1x is equal to 9. -1x is equal to 9. How do I remove that -1 from the x? I want x to be by itself. How do I remove it? Someone tell me. What operation do I use? Multiplication or division? Amanda? Sorry? Division. Thank you. So divide, and this is what it looks like. Dividing both sides by -1, dividing both sides by -1, I get a final answer of x is equal to -9, because +9 divided by -1 is -9. The exact same operation for question number 10, except we have a different constant number attached to the x, or we call that a coefficient. Remember our first algebra, the 5 is a coefficient, right? 5 by itself would be a constant number. 5 attached to the x is coefficient. To get rid of that coefficient, I have to remember I have to divide both sides. I can't tell you how many tests I've marked where students are just doing the one side. They're not performing equal treatment in algebra. So we have to divide both sides by the 5. So 5x divided by 5 is equal to x. X is equal to 30 divided by 5. So that means x is equal to positive 6. Positive 6. Okay, so this is another challenging problem. X over 7 is equal to 3. X over 7 is equal to 3. So remember, 7 is in the denominator, so it's an operation of division. In order to correct this, we are going to multiply both sides by 7. Multiply both sides by 7. So I have 7 times 3 on the right-hand side, 7 times x over 7. 7 times 3 and 7 times x over 7. Now, the 7s cancel each other out. So we have x by itself on the left-hand side, and 7 times 3 is 21. And that is my answer for the right-hand side.